This is Peter Bresnan from OneSails Palma, and I'm here to talk to you about the Tradewind Sail. There are a lot of questions that have been asked through our various social media channels at Met's trade show, and different sites from different sailmakers around the world have been asking lots of different questions. So we thought we'd compile all these questions into a list and try and answer them one by one. As the first video we produced about the Tradewind Sail suggested straight away, this is not a new concept. We said it pretty clearly then. We're not trying to say that we've invented anything new. What we're trying to say is that we've taken an existing concept and refined it in as many ways possible to make it a more user-friendly, more dynamic, more useful, lighter, safer, lots of attributes we can label our sail with. So is this sail actually innovative? It's innovative in its use of materials and its design and the multifunctional aspect of it. So the twin sail dead downwind setup has been around for, I'm going to say hundreds of years. Classically and traditionally, it's two upwind sails, two Dacron sails or two laminate sails or two upwind oriented sails that are set side by side so that the boat can go dead downwind. In more recent times, there have been lighter Dacron crosscut versions with anti-torsion cable and a furling system. And we've taken it simply one step further. We have integrated our IFS technology and a radial cut and an interesting hybrid shape design. So is it actually innovative? It innovates on an existing idea. Number one, the multi-purpose aspect of it, and it comes from the IFS structural lens in the luff. To sell yet another sail that is going to be used on a narrow wind range isn't really something that we were looking to do. We wanted a multifunctional sail, but not just multifunctional at a low efficiency rate, but multifunctional at a really high efficiency rate so that it works well at those wind angles and wind strengths. So the sail needed to be light for low wind conditions, and it also needed to be very strong for strong wind conditions, and it needed to have shape holding. If there's no shape holding in the critical luff part of the sail, then the sail just becomes yet another high drag, low efficiency sail that you're trying to use on a reach or on a shy reach sort of upwind. So it was very important that the sail had a good amount of shape holding, and that's provided by this high modulus structural lens. What does high modulus mean? That it means it's very low stretch. We're using continuous fibers from the tack to the head, and those fibers are uninterrupted and they are high modulus. Their elongation is 1.2%, meaning very, very low stretch. Dyneema on a rope will have 2.5%, 3.5%, 4.5% elongation. Even very high grade SK99 Dyneema rope will have 2.5% elongation. So 1.2% elongation means the sail does not stretch. And when I say stiff, I don't mean stiff like cardboard, but stiff in the physical term, meaning it will not stretch very much at all. Obviously 1.2%. Well, a symmetric spinnaker is attached to the head, and it needs to be attached to a spinnaker pole, or in the case of a parasailer, you don't necessarily need a spinnaker pole, but you do need, quite a few bits of rope to connect each clew to the bow or back as an after guy. So still, you need quite a few more ropes than you would for our setup to control a parasailer. So the benefit of this sail versus a spinnaker or a parasailer is that the tack is fixed to the boat. So you have the head and the tack, which are fixed to the boat, and they are taut. The luff of the sail is taut. If you've seen a spinnaker going downwind in waves, you will see the sail oscillating port to starboard as the boat rolls from one side to the other. This is significantly reduced with a sail where the tack and the head are fixed and taut between the 2 points to the boat and to the mast. So, comparison to symmetric spinnaker, it's more stable. There's actually a greater area because the spinnaker does not come all the way down to the bowsprit or to the bow of the boat. And this sail comes all the way down to the bow of the boat or to the bowsprit. So you gain a lot of area there. We go on to point number 2, And we've been asked to explain the basics of this solution's aerodynamics. Absolutely. I have used this sail in 18 knots of true wind speed at 90 true on a catamaran with no mainsail. And the boat was thundering along at 9.5 to 11 knots nearly with no mainsail on a 90-degree true wind reach. So I can tell you that the sail works on a reach. The apparent wind was well forward of the beam, something like 60, 65 apparent wind. So yes, it does. Is it strong enough? Of course it is, because you're pulling on two sails with one sheet. So a single sheet connected to both sails, you have a twin ply or two skin sail. The twin luff lens, so we talked about this high modulus structural lens earlier on. We have the front 15% of the sail, let's say, which is made of a high modulus structural membrane, which is very, very, very low stretch, the lowest stretch of most materials on the market today for any type of sail. And so this gives the sail fantastic shape holding. It's also the element which allows the sail to be furled. It transfers the torque from the furler up to the head instead of carrying a heavy-duty anti-torsion cable. Well, a spinnaker, which is oscillating from side to side, will tend to make the boat roll. This sail does not oscillate from side to side because, like I said to you earlier on, the tack and the head are fixed, and the line between the tack and the head, the luff line, is taut or tight. So therefore, it's acting like a forestay without being a forestay. So the sideways movement of these two sails is much reduced compared to a spinnaker or a parasailer. It's a very interesting question, a very precise question, because it is acting as two separate wings rather than one balloon-style, semicircular shaped, let's say, wing. It's two of them. So the flow is traveling dead downwind and then gets diverted to sideways and around the sail. So something like this is a sort of description of what the wind is doing. It's coming dead downwind, hitting the center of the sail. It's then oscillating outwards or rotating outwards and then rotating back along the center line. That's in our wind flow analysis what we've seen that happens. The beauty of making it out of nylon, light to medium weight nylon, is that in light winds the sail would take its shape very quickly. When you build a heavy sail designed for medium to strong winds, the sail will not take its shape until the sail sees those medium to strong winds. Here, the sail is made out of a medium nylon, and it will take its shape, very quickly. So the advantage of making it out of a radial construction, meaning that the panels are oriented along the load lines, and making out of a light medium nylon, means that the sail takes its shape very quickly. So to answer the question, how does it behave in light winds? Well, it behaves very well, because it is a light medium wind cloth, and it takes its shape, its design shape, very quickly, and behaves in an efficient way as an efficient foil or efficient wing very quickly. Had this been made out of a heavier nylon or a heavier Dacron, it would have required more wind to take its shape. So therefore, how would it behave in light winds? Not so well. So to recap, it behaves well because it's light. It behaves well because it takes its shape very quickly because it's light, and therefore we can achieve its design shape with less wind. So does it behave well in light winds? Extremely well. Well, dead downwind and 6 to 7 knots of wind, we were doing between 3.7 and 4.5 knots of boat speed, dead downwind without a mainsail up. So you might think that's low boat speed, but considering you're going with the wind, not generating any apparent wind, that's actually very good numbers. In the Tradewind sail configuration, the sail that we designed for the Privilege 510, we're quite confident to say that we could carry it up to 30 knots true. On that particular catamaran, we'd be doing 12 to 13 knots. So the apparent wind would be something like 16, 17 knots. And for that sail, we're pretty confident that it would take it structurally without any kind of problem. In the twin sail configuration, so you're now reaching 90 degrees true, I personally used it in 18 knots true, and it's been used up to 20 knots true without the mainsail on a 90 degree true wind angle reach, and with the boat doing 10 knots. It's important to make the point. The sheets have to be connected. One sheet has to be connected to the two sails. So you need to be pulling on two sails, not on one. That's a very important point to make. And there is an example of what we achieved, with some 2-meter swells, 90 true wind angle in 18 to 20 knots true. If you put the main up with a reef, some of the load comes off of the Code Zero, or the multi tradewind I should say, and goes onto the main. So the sail has an even bigger factor of safety. Monohulls have used this version of the Tradewind sail from other sailmakers in the past very successfully. They've used the spinnaker pole or the boom or both to hold the clews outboard as much as possible to give the boat as much stability as possible. So once again, we are evolving an existing concept with as many technological advances as possible, but other sailmakers have produced this sail in a much more basic form with fewer advantages, and it has worked just fine. However, with a view to carrying out our due diligence, we are building a multi-tradewind sail for a monohull, and that monohull will be quite an old style, stern, pinch stern, narrow, quite rolly boat, so that we can prove the question about does it induce or does it stabilize. So watch this space for the next video about the multi-tradewind sail on a more classic designed, more rolly type of hull form. Well, it can be as big as about 150 or 160% of your 4-triangle base. So if you have a Genoa with, let's say, a 5-meter foot, then one side of your tradewind sail will be 160% of that. So it could be between 7 and 8 meters of foot length per side. The sail is describing an arc. So each of the two sails is describing an arc, and therefore the foot length can be quite long. Typically, it's bigger than a spinnaker, quite a lot bigger than a spinnaker, and it's actually bigger in some instances than the main and the normal downwind gennaker put together. It is really a big sail. It can be made smaller, of course, and it depends on your individual choice what you're trying to do with it. The first tradewind sail that we made was aimed at reducing the big performance downside of a catamaran in very light winds. So we made it not quite as big as possible, but we were conservatively high in sail area. For the Privilege 510, I believe it was nearly 200 square meters for that boat, which is is a very, very, very large downwind sail. The downwind gennaker that we produced for that boat was 163 square meters, so it's significantly bigger than a gennaker. So it's almost the size of a gennaker on that particular boat and the mainsail together. So it can be very, very big and very powerful. It can also be reduced area. It really depends on customers' specifications and what we're trying to achieve with this particular sail. So the concept is, if you're using a sail in light, medium, and even medium strong winds, there's no need to do anything different. You're using it without your main, there's no need to do anything different. Just fly the sail as you would any kind of downwind sail without any kind of concern. The moment you get into medium strong, or really quite strong, such as 30 knots, then it's useful to connect your main halyard to the back of your boom and tighten it, and then tighten the main sheet against the boom to act as a backstay. That's going to alleviate some of the rigging load on your permanent V1s or backstays, however you want to call them. Remember, this is a nylon sail. The front is laminate, yes, but the rest of the sail is nylon, and nylon is a stretchy material. That's why it's so forgiving. So mass compression is very, very low. The tension on the luff, on the cableless luff, on a 50-foot boat, probably doesn't reach 1,000 kilos. And if you consider that you could be going downwind with a Genoa, with its halyard load, and a staysail with its halyard load, and a mainsail with its halyard load, those 3 halyard loads would easily surpass the 1,000 kilos that we estimate the Privilege 510 had on the luff. So mass compression is hugely reduced compared to a setup that everybody would consider safe. Full main, full jib, full staysail, going downwindish, sort of 140, 150, 160 maybe. With this single sail, the compression is significantly reduced. So if you're worried about that compression part of things, you need not worry. The Dacron or laminate sails that you could be using with this 3-sail setup, like Maine, Staysail, and Genoa, those laminate sails are extremely stiff. So all of the power from the wind gets transferred to the sail, to the halyards, to the tack, to the clews. So expect there to be far more compression because you've got 3 sails, and because those heavy Dacron or laminate sails require far more luff tension than the multi tradewind sail. The 2 sails are being sheeted together. The 2 clews are together and the sheet is pulling the 2 clews together. My personal experience is that I couldn't even tell that there were 2 sails together. This may sound like blatant salesmanship, but it's just a fact. I was very carefully looking at the leech and at the foot of the sail, and I could not see a millimeter of movement, even in the 18 knots, 20 knots of true wind on a beam reach with 2-meter swells. It almost looked like there was a single sail. I could not see a millimeter of movement. In fact, I couldn't even tell that there were 2 sails there because they're 2 identical sails. Also bear in mind, it is a light, thin material that is, like it or not, quite stretchy. So rather than chafe, there's going to be increased elongation. So the sails will move together and breathe together. Rather than being any shearing forces, there will simply be some suction or pressure forces moving both sails together, making them deeper, making them shallower, or flatter, I should say. The sail has now reached the Caribbean. It's been up a lot. No chafe issues reported, apart from on the lashing on the head. That's seamanship. Every 24 hours, you should furl the sail, bring it down, check the lashings on the head, which you cannot see, obviously, to make sure that everything's fine. So, other than basic seamanship of furling the sail away, bringing it down, checking the lashings, there's nothing to do. There's no added chafe because the 2 sails are together or not. So, considering the thousands of miles that the sail has done already to the Caribbean, it went from Palma through the Gibraltar Straits to Cape Verde and across the Atlantic, and no chafe issues have been reported at all. Well, with the multi tradewind sail, it's the best solution you could possibly have. There really isn't a better one than that one. With your standard setup with a spinnaker, you'd have to ease the sheets and douse the spinnaker. You'd have, flapping sheets, a flapping sail, quite a dangerous situation. And you'd have to maybe go up on the foredeck and pull the sail down. It's dark, it's gusty, it's rolly. You're not necessarily on a stable catamaran platform, you're on a rolling monohull. Here with the multi tradewind sail, from your cockpit, you engage the furling line and start to furl away as you ease the sheet slowly. There's no flapping sail. We don't want you to ease the sheet so that they flap. In extremis, in an extreme situation, we may want you to do that, but the standard procedure is put the furling line around the winch and start to furl away. Once you started furling away, you ease a meter of sheet, furl away some more, ease another meter of sheet, furl away some more. It is all really rather controlled. And we would rather you do it that way because it means you will get a better furl. If you ease a lot of sheet and the sails are flapping, then it's likely that you will not get a tight furl. The leech will be flapping and loose, and when you furl it, you will not have a tight leech. And if you want to be able to leave the sail up, you need a tight leech, just like furling your Genoa or your jib. You don't ease your jib completely, let it flap, and then furl it away very quickly. With a Genoa of any material, you will find you'll have a very loose leech. So once again, common practice, good seamanship, and good practice to take care of your sails is, you start to furl, you ease the sheet, furl a bit more, ease a bit more sheet with the tradewind. With a Genoa, you'd ease a little bit of sheet and furl, ease a bit more sheet and furl, ease a bit more sheet and furl. It's a gradual process, which encourages you to be, more under control. Remember, when you're going dead downwind and you need the maximum power and the maximum lightness so that the sail takes its design shape, the sail is in single skin configuration. When you're on a reach and you want the sail to be strong enough and have good shape holding and be aerodynamically efficient and keep its shape aerodynamically, that's when you want both sails to be working together. So really no concern about the weight. When you want the double weight, you've got it, that's on a reach. When you want the single weight, you've got it when you're going dead downwind. Our colleagues on the Privilege 510 set their autopilot, set their sail, and noticed that reliably the boat could steer plus or minus 15 degrees from dead downwind. So dead downwind is 180, plus 15, minus 165 on one tack, 165 on the other tack. So essentially, the boat can veer through plus or minus 15 degrees, and the sail design is such that it will not collapse or start to flog. That's the report that we've received. My personal experience is, in 4 to 8 knots of our first sea trial, obviously the autopilot is very precise. When we got up to 16, 18, 19 knots, we never saw the sail flog, and the autopilot was not, performing minutely to the last degree. We were probably doing plus or minus 10 degrees. So across the Atlantic, it's been plus or minus 15 degrees. That's a huge improvement on what I saw, and nothing had changed. That's just the reality of the sail design. The sail is able to cope with plus or minus 15 degrees. That is an interesting question, because catamarans can be very light and you could easily overpower them. There's a very useful function to this multi-tradewind sail with this structural lens. You could simply ease the sheets and have the sail twist more. In the same way as you would ease the sheet on your main to twist the top of the sail and depower it and stop it from heeling the boat over so much, you can simply do the same thing. Just ease the sheets another meter, the clews will go forward a meter, the sail will twist open more, and you will generate less power. On an aerodynamic front, this sail generates some upwards lift because the sail itself is angled. It is going from the top of the rig to the end of the boat to the end of the bowsprit, and as the wind is hitting the sail, it is being deflected downwards. Well, Newton's law, equal and opposite reaction. Well, where there's a downward load, there's got to be an equal and opposite upward load. So the sail is being pushed upwards, which is raising the bows of the boat. It has a bow lifting force, not a bow pitching or bow sinking force. So that answers the question of, can I pitch more my catamaran? You can if you leave it up in far too much wind with big waves and the boat is overpowered. So ease the sheets, or furl the sail away, unfurl it only on one side. You have essentially halved the area and you can still keep on going dead downwind. The privilege, instead of 200 square meters, we'd be down to 100 square meters. We'd be able to fly it on only one side, still dead downwind, plus or minus 15 degrees, and you've essentially reefed the sail by 50%. What that means is, and we've heard it firsthand from some of our customers who have flown a parasailer in far too much wind, they've gotten very confident and all of a sudden they're in 25 knots of wind and they're wondering how they're going to get it down. And essentially what's happened is the sail's exploded because it's just overranged. That doesn't happen with the multi-tradewind sail. You furl the sail away and you'll probably have a good furl because the sail furls very well. It has 2 IFS lenses. Our Sailmakers and our Code Zeros have a single IFS lens. This has 2 of them. So already the IFS Sailmakers furl very well. This Tradewind sail will furl twice as well. So our experience is that it furls very, very well. So even in very strong winds, the sail will furl and it will furl tightly and you'll be able to leave the sail up. So do you have any nightmare stories from I can't get it down? No, because you can just furl it up and leave it up. I've had our IFS Sailmaker up in 35 knots of apparent wind speed. So the sail was seeing 35 knots of wind and the sail did not unfurl, or didn't even look like it was going to unfurl. So my personal experience is 35 knots of apparent wind speed on an IFS furled sail, and there were 0 issues. This has got to be aimed squarely at those crews that need something really easy. Forget the main with all the chafe related issues with battens and shrouds and lazy jacks, etc. Forget the jib and the staysail that are just too heavy and just not designed for these wind angles, and unfurl this tradewind sail either on a reach or dead downwind. When you're worried about it, reef it down by completely furling it, connecting the 2 clews to one side and opening it on one side only, as if you were using it as a Code Zero. So a twin skin, dead downwind Sailmaker, that's what you're creating. So twice as strong, half the area. That's really a very, very strong and very safe setup that you can use until the wind increases even further to give you peace of mind. Remember, we don't have an aluminium foil that acts like a torque tube. It's relying solely on the high modulus, strong IFS lens. You cannot partially furl it like you would partially furl a furling Genoa or a furling staysail. Yeah, it's either completely out on a twin skin setup, or completely out on a single sail setup, or it's away. If you want to depower, ease the sheets, have both sails on one side, or ultimately furl it away and take it down. Absolutely, there's no rush to do anything. So as you are furling away with your winch handle or with your button or whatever you've got, as you're furling away with your winch, you stop furling away, you ease a meter on both sides, and you keep furling away, ease another meter. So one person can absolutely do this. You need an autopilot or you need a wind vane, something to keep the boat tracking that downwind. So if you have an autopilot or a wind vane and a winch, you will be able to furl away and ease the sheets perfectly safely. Any sail is dangerous in a squall, but a multi-tradewind sail I think is far less dangerous because you can simply ease the sheets and spill power. The tack and the head are connected. So easing the sheets on a spinnaker, what would happen? The sail would simply just collapse and flog and start to oscillate port to starboard a lot more. So any other dead downwind sail would simply start to oscillate more and become more dangerous. It would rise up in the air and the center of effort of the sail would rise and it would start to induce more rolling, which is obviously dangerous. So does it become dangerous in a squall? Any sail becomes dangerous in a squall, but this multi-tradewind sail is less dangerous than all of them put together because it is fixed at the tack, it is fixed at the head, and the sideways rolling motion is significantly reduced, firstly. Secondly, you can ease the sheets without the sail flogging. And finally, if you do get a huge gust coming through, then ease the sheets completely and have the sail flag, both sails flag in front of the boat, and simply furl away the sail. Yes, you'll have two sheets that will be flogging, but you probably have a 50-knot squall, and you're not too worried about the flogging of the sheets, but what you are worried about is getting the sail furled away. So ease the sheets completely, have both sails flagged in front of the boat, streaming in front of the boat, and furl the sail away as quickly as you can. Absolutely not. Like I said before, it's not a new concept. Other versions of this sail have been produced before we produced this one. And monohulls and catamarans have been using it. So no, it's not only for big cats. Even small 24-foot boats use them. You can use the boom as a spinnaker pole. There's no main up, obviously, so you use the boom out as a spinnaker pole or a whisker pole or a jockey pole, or you can use a spinnaker pole on the other side. So there's no size limit, upwards or downwards. For small boats, monohulls or catamarans or trimarans. One of the benefits of the IFS system is you don't have a heavy anti-torsion cable. You have a soft structural luff, two of them in the case of this sail, and that's soft and pliable. It is a thin, soft, pliable material. It's not a heavy, thick anti-torsion cable that requires a minimum bend radius so you don't damage it. So it takes less space than any other tradewind sail out there, which is one of the innovative aspects of this sail. Absolutely, put it up before you leave the marina. If we've applied UV protection to it, put it up before you leave the marina, head out to sea and use it for a mile, 2 miles, 3 miles. It's so simple to furl. It's no different to your furling Genoa, except it's a lot bigger, more powerful, it's easier to handle, and you can use it on a variety of different wind angles. So yes, use it and deploy it for short runs. It doesn't take longer to set up than any other furling sail. It's exactly the same as your Genoa. When you want to furl, you start to pull on the furling line by hand or with a winch or with a button, whatever, and you just ease both sheets slowly as you furl. No difference at all. You furl it as a tradewind sail or you furl it as a Code Zero. No difference whatsoever. Any boat with a standard system for hoisting a spinnaker or a gennaker has the gear required to use the sail. You need a furler, a spinnaker halyard, and 2 spinnaker blocks at the back of the boat. That's it. No, you don't need a 2-to-1 halyard. A single 1-to-1 halyard is enough because the IFS lens is taking the load and you don't have an anti-torsion cable that resists torque and tries to spin the halyard. You don't need a 2-to-1. 1-to-1 is absolutely fine. We've even used a 1-to-1 on a 100-foot boat with an IFS gennaker without the need for a 2-to-1 halyard. Dead downwind is extremely easy. You can oversheet the sail and it will still push you along nicely. You can trim it perfectly and you've got the best efficiency. You can even undersheet it and have the sail too far forward and the sail too twisted, and the sail will still work. It won't flog. So is it hard to trim? No. There is a huge amount of scope for getting it wrong on the too tight side or on the too loose side. Like I described earlier, real life situations is plus or minus 15 degrees. So from 165 on port to 165 on starboard. It's not hard. It's meant to be autopilot friendly and helmsman friendly, so you don't have to be eagle-eyed on the sail at all times because you're worried about it collapsing. Absolutely. If I owned a cruising boat right now, one of the first things I would do is buy one of these sails. And once again, I don't mean to sound terribly commercial here, but it's been such an eye-opener, such a breath of fresh air, this sail, that it's even got us Sailmakers excited about having one and using one instead of hoisting the main, and the jib, just unfurl this IFS Tradewind, use it as a code 0 or dead downwind. I think that comes to the end of the many questions that we've had. If you've got any more, feel free to post them. We will collate the latest set of questions and try and answer them in this sort of way. Otherwise, send us a message via the usual social media channels, and we'll be very happy to answer all of them. Thank you for your time.